This is Algebra 1, Lesson 21b, Addition of Like Terms with Exponents. We're going to be doing examples 21.5 through 21.7. A little bit of review first. Remember when we talked a couple videos ago about like terms? These are like terms. First of all, I know they're terms because they're separated by a plus sign. If you're separated by plus or minus, then those would be terms. How do I know they're like terms? Well, they have the same variable. They're going to be equivalent variables. And I could list this out the long way. That's what 3x's would look like, plus 2 more x's, and that would be a total of 5x's. What would you do with 3x squared plus 2x squared? Well, let's write that out. X squared plus x squared plus x squared. That's the 3x squareds. Now let's add 2 more x squareds. And that would be a total of 5x squareds. So in this video, they're showing you, in this lesson, they're going to show you that your like terms have to have the same variable raised to the same exponent. So x squared and x squared are like terms, just like x and x are like terms. Addition and multiplication are often confused. This is a very common error. So we're going to try to address it from our foundation here. What would I do if I were going to try to add x squared plus x? Well, I see I have 2 different terms here, but are they like terms? This one is x and this one's x. Looks good so far, right? But this x is raised to the second power, whereas this x is raised to the first power. So these are not like terms, and you can't combine them. You would just simply leave it like this. Let's look at this one. This I can do. X squared times x. X squared is x times x, and then times another x is x cubed. And we talked about in the last video that we know that this is a 1, exponent of 1, and we can combine these and say that's going to be x to the third power. Now, why am I able to combine these, but I couldn't combine the one before it? Well, notice that the first one, these are terms. I'm separated by a plus sign. But here, this is one big term. I don't have to worry about having like terms because I've only got one term. It's being multiplied, and we know how to do that. So don't let that confuse you. Practice enough of them to convince yourself of it. Now for this, I do have 2 different terms. They're separated by plus signs. Let's look at the variables. I've got an x squared, a y, and a p to the 5th. So these are like terms, and I can add them. How many of these do I have? Well, there's nothing in front of it, so there's just 1. How many of these do I have? Nothing in front of it, so 1. So I have 2 x squared y p to the 5th. And that's my answer. I can simplify that. Those are like terms. Here, I have an x, y squared, p to the 5th. I have an x, y squared, p to the 5th. There's 1 of these and 1 of these. So my total is 2 x, y squared, p to the 5th. Here's the first example. Simplify by adding like terms. Now we need to be careful to make sure we're looking at like terms. So we see our different terms here. We have 4 terms. Term 1, 2, 3, and 4. Okay, let's look at those and see which ones are like. I have an x squared y p to the 5th, and I have an x squared y p to the 5th. This is an xy squared p to the 5th. So that's different. It's not an x squared, right? The y is squared. So I have an xy squared p to the 5th. And then here I have an xy squared p to the 5th. So I can combine those. So let's combine the first and the third term. Here I have one of them, and here I have three of them. So I've got a total of 4 of them. The second and the fourth terms, I have a positive 2 of them, and I have a negative 7 of them. So when I combine them, I subtract and get 5. Take the sign of the one with the largest absolute value, which is the 7, so it's negative. And then I keep my variables. I have an x, y squared, p to the 5th. Example 21-6. If you have trouble with these, copying these, maybe your eyes are starting to cross because they can get kind of long and lots of little differences, I've found it helps if you have a colored piece of paper. A colored index card works really well that you can put underneath the problem in the book as you copy it onto your notebook paper. You can try that and see if it helps. Let's look at our terms here. They're separated by these plus and minus signs. So we've got 4 terms again. Here I've got an m cubed xy squared p, okay? I need another m cubed xy squared p. Oh, look at this, m cubed xy squared p. Okay, so that's the same. Here I have an xy squared m cubed p. xy squared m cubed p. Is that the same? xy squared m cubed p. Yeah, it's the same. But here I have an x squared m cubed p, or I'm sorry, I didn't say the y first. A y x squared m cubed p. Do I have that same thing anywhere else? I do not. So in 21-6, the first 3 terms are like. I have a positive 2 of them, a positive 3 of them, and a negative 10 of them. So let's combine this 2 with this 3 would give me 5 positives. And then this negative 10, we would subtract and get 5, take the sign of the one with the largest absolute value, so it would still be negative. And then I copy my term down, m cubed x y squared p. Okay, and then I just copy down this one over here that doesn't have a term that matches it. Y x squared m cubed p. And this is our final answer for 21-6. Remember that if some of the variables are in a different order, that's okay when it's all multiplication. Example 21-7. Let's look at our terms. Here I have 1 term, 2, 3, 4. Ooh, we're up to 5. Okay, so we've got 5 terms. Let's look at our variables. We have an x squared y. This is an x squared y. This is not. The third one is not. The fourth one is an x squared y. And the 5th one is not. Let's go back and look at the third. It's an x squared y squared. And the fourth one is an x squared y squared. So those two match. So I'm just kind of sorting them. Okay, it's like sorting socks, right? You dump the laundry on the bed, the clean laundry, and you're matching the socks and putting together the ones that go together. So we're going to count up how many x squared y's we have. We have 2 of them plus 3 more of them, which gives me 5 of them. And then I'm taking away how many? Well, there's 1, right? So I've got 2 plus 3 is 5, and then I'm taking away 1. So there's 4 of them. Then I'm going to count up my x squared y squareds. Here I have 1 of them, and here I have minus 4 of them. So 1 minus 4 would be negative 3 of them, and they are x squared y squareds. So this is your final answer, 4x squared y minus 3x squared y squared.